This lesson deals with Supplemental Problem 213. You can find this problem in the course ebook in the Chapter 2 Supplemental Problems on page 14. A potentiometer, or pot for short, is a three-terminal device with either a rotatable shaft, an adjustable set screw, or a slide. Here's an example of the rotatable shaft where you have one rotation from one end to the other. The adjustable set screw is here, and you can turn this many times. And the slide is sliding it from the bottom position to the top position. Now what's inside here between terminals A and C is a piece of carbon mixed with some other material to create a resistance. Terminal B is connected to the shaft with a piece of carbon in the form of a wedge. And that wedge moves as you rotate the shaft, turn the set screw, or slide the slide. And between terminals A and B and C, there's a resistance. Let me just show that with an equivalent circuit. Pot has some total resistance, and between terminals A and B, their resistance we'll call R1, and between B and C, a resistance I'll call R2. So R1 plus R2 equals R pot. Now let me introduce another symbol, alpha, which is a number between 0 and 1. If this resistance is alpha times R pot and the total is R pot, then what's left over is R pot minus alpha R pot, or just pull out the R pot. In other words, the sum of these two is just equal to R pot. In other words, the alpha R pot and minus alpha R pot cancel. This is the percentage of the rotation of the shaft or sliding of the slide. If alpha were a quarter, you'd have a quarter of the resistance here and then 3/4 of the resistance here, and so on. Could you use a pot to make a voltage divider and derive an expression for V out as a function of alpha? So let me draw it this way as A, B, and C, where here's R1 and here's R2 as described above. V out is R1 over R1 plus R2 times V sub S. Just think of this as just really two resistors in series. Now R1 we're saying was alpha R pot, and R2 is 1 minus alpha R pot. So in the denominator, we get the alpha R pot and the minus alpha R pot canceling. We're just left with R pot. In the numerator, the same thing, and that drops out. V out is equal to alpha times V sub S. If we were plotting that, it's just a straight line. As you move from one end of the shaft to the other, from the bottom of the slide to the top of the slide, from the start of the set screw until the end of the set screw, you can adjust the voltage in a linear fashion. All this is assuming that there's nothing hooked up here. Or what's hooked up here is much larger than R1 in resistance. In the next supplemental problem, we'll take a look at what happens if you have something hooked up here, and some very interesting results. This is how you can make a voltage divider out of a potentiometer. And this is supplemental problem 213.